Okay, now we want to look at solving some equations, exponential equations. We'll start with some that we're familiar with. You know, 2 to the x equals 8, and say, well, yeah, I know I could do that because I need to put them on a common base, and I can express 8 as 2 cubed, right? So I can say this is 2 cubed. And right away, since the bases are equal, I can equate the exponents x equals 3. Easy enough, okay? Same thing over here. I can, of course, say that's 3 to the 2x plus 5, and I can make that 27. That's be 3 to the negative 3. So 3 to the 2x plus 5 equals 3 to the negative 3. And then I can say, well, okay, that means 2x plus 5 is equal to 3. So 2x looks like it's equal to negative 2. So x equals negative 1. So they weren't so bad. Everybody seemed to be okay with those. All right. Let's look at why that works, of course. Why is 2 to the x equal 8 work? Well, again, remembering the graph of y equals 2 to the x, it looks like this. So that there is y equals 2 to the x. Okay, that there here is y equals 8, and they would seem to be intersecting at that x value of 3. So that's why that works graphically. Okay. But now we pose this problem to you, okay? How do we proceed to solve 2 to the x equals 5, okay? Or 5 to the x equals 17, okay? Certainly, they should have a solution because, like, if we just go back to this graph, y equals 2 to the x, it intersects the horizontal line of 8 at the x value of 3. Well, certainly it's going to intersect some horizontal line y equals 5. But where? Well, I mean, approximate, it's going to be something greater than 2, something less than 3. But at the point here, we're left with a problem, okay? We don't know where it intersects, okay? So what we have to do is we have to incorporate our calculator. So for these exponential equations for which we cannot solve them by hand, we have to go to the calculator, and what we're going to do is we're going to take the log. We're going to turn the exponential equations into logarithmic equations, just as previously we turned log equations into exponential equations. So in other words, I'm going to say, let me take the log of both sides. Now taking the log says, well, what log? Log what base? Doesn't really matter, okay? Doesn't really matter. So let's just say we're going to take, log base 2, since this is already base 2. So I'm going to take the log base 2 of 2 to the x, and I'm going to take the log base 2 of 5. Well, log base 2 of 2 to the x, by the incorporating our appropriate rules here, would give us x log 2 of 2 is equal to log 2 of 5. All right, and of course, log 2 of 2, this thing right here should be identified as 1. So it says x is equal to the log base 2 of 5. Now you say, well, what is that number? Well, we have to find out. Okay, without a calculator, we certainly can leave it that way, but we want to know the decimal value. We want to know to what power must 2 be raised to produce 5. So again, we're going to call on our calculator, but here our calculator doesn't have log base 2, so we're going to have to do the log conversion and say that's log 5, or if we prefer, let's go, since our calculator has the keypad with natural log. Let's say the natural log of 5 over the natural log of 2. And again, we can pull that on our calculator and say it's the natural log, right on the keypad there, natural log of 5 divided by the natural log of 2, and that should give us, okay, the value of 2.31. So which is to imply that 2 to the power 2.31 will give us the value of 5. Okay, so that looks like it was approximated. Again, we are approximating these because this is actually an irrational number. So same thing here. Let's say I wanted to find out what x is. I'm going to take the log. Let's just say for sake of argument, I'm going to take the common log. Log base 5, log base 10 of 5 to the x equals the log of 17. All right. Now I'm just going to, use my power rule, make that x the log of 5 equals the log 17. And then I can simply divide by log of 5, which will isolate my x, and say that x is equal to log 17 over log 5. And believe it or not, that's quite an acceptable answer, okay? Log conversion would say that's the same as the log base, the log base 5 of 17. I know you want to know decimal value because you want to know to what power must 5 be raised to produce 17. Of course, it's got to be less than 2 because 5 squared is 25. So again, we're going to call on our calculator. All right, call on our calculator and ask. This time we're going to go to common log. So again, common log is in the catalog, and there it is. I want log 17 divided by, put the parenthesis in there, log 17 divided by log 5. Go back catalog for log 5. And I get 176. So 5 to the 176 is 17. Okay, so that's the guts of it, and we're going to put a stall on it for now. Come back and do a few more interesting problems. So in recapping, what we're saying, in some certain exponential problems are non-calculator based because we can put everything on a common base. Those which are not, remember, graphically they have a solution. Okay, so therefore analytically we should be able to find it. And we can find it by taking the log of both sides. And again, what log? Whatever log you desire, whatever base log you desire. You might want to just prove it to yourself by going back and doing 2 to the x equals 8 and taking the log of both sides. Take the log base 10, take the log base 2, take the log natural log, okay? Doesn't matter. You'll end up getting 3. Just try it, okay? So there you go. Like I said, we're going to stop it for now and look at some more interesting problems in the next video.